All right, number one, matrices. I will leave that for later. Do you use a calculator to find matrices? If not, we can go through different methods. What do they have? Gaussian elimination and the, it's not Crawford, Kramer's rule. I don't think many people do that, but hopefully you're doing it with a calculator. All right, let's see what the next one is. Question 2, 3, 4. I do not understand on how to set the word problems or solve. All right, here's number 2. Now, word problems generally end up having a value equation and a number equation. And then we'll see how to solve them after we set up the equation. So let me take, okay, that's not going to work. I guess I have to make this smaller. There we go. Hold on, just be patient. I'm putting it over here. Okay. So there's going to be a number equation and a value equation. And if there's 3 variables, maybe they'll give us one more. So let me see what it says here. It says, Heather downloaded some television shows, a sitcom. I'll call sitcoms S. A drama. I know it's supposed to be drama, but I like to say drama. I'll call that D. And a talk show, T. Now, what is the value equation here? The value equation is going to be the gigabyte equation. I'll call it GB. The gigabyte equation says a sitcom is 0.3, so 0.3 times S, 0.3 gigabytes per sitcom times the number of sitcoms, plus 0.6 gigabytes per drama times the number of dramas, plus 0.6 gigabytes per talk show times the number of talk shows, equals a total of 3.6 gigabytes. Then it also says there's 7 programs, so sitcoms plus dramas plus talk shows equals 7, and hopefully there's one more thing. There were twice as many episodes of the drama as the sitcom, so sitcom equals 2D. Twice as many. So if there's one sitcom, 2 times 1 is 2. Or one drama, 2 times 1 is 2. There'd be 2 sitcoms. So I've got those 3 equations, and now I will use this one, and I will plug it into both of these. So each one of those equations, the resulting equations, will have 2 variables. So I'm going to get rid of one of them. Then I'll have 2 equations, 2 variables, and I can solve for those 2 variables. So let me see. I'm plugging in 2D for S. So this is 0.3 times S, but I'm putting in 2D for S. So 0.3 times 2D is 0.6D. I just plugged 2D in for S. So this S becomes a 2D. 0.3 times 2D is 0.6D plus 0.6D plus 0.16 equals 3.6. Now I will add these like terms. 1.2D plus 0.16 equals 3.6. I will also plug 2D in for S in this equation. So that's going to be 2D plus D, which is 3D, plus T equals 7. Now, I'm going to try to get rid of one of these. I will multiply this second equation by negative 0.6, because that way this will become negative 0.6t, and that'll cancel out with that positive 0.6t. So negative 0.6 times 3 is negative 1.8d. D minus 0.6t equals 7 times negative 0.6 is negative 4.2. Let me scroll over just a little bit so I can get that there. Now I will add these 2 equations. 1.2d minus 1.8d is minus 0.6t. These cancel. 0.6t minus 0.6t is 0. Remember, that's 4.2. 3.6 minus 4.2 is negative 0.6. And then d equals negative 0.6 divided by negative 0.6 is 1. So now I know I have 1. I'll put these over here. Drama. What's the other one? Sitcom and talk show. I have 1 drama. Well, sitcom equals 2 times drama. So sitcom equals 2 times 1 equals 2. So there's 2 sitcoms. And that would mean 2 and 1 is 3. That would leave 4 talk shows. because they have to equal 7. Now let me just double check to make sure that works. 0.3 times 2, I'm just plugging in those values I found, plus 0.6 times drama, 1, plus 0.6 times talk shows, 4, should equal 3.6. I'm just double checking to make sure I got all these right. That's 2 times 0.3 is 0.6 plus 0.6 plus 2.4 equals, that's 1.2 plus 2.4 is 3.6. So got it. I verified it. So that's how I set it up. And again, there was a value equation. In this case, the value is gigabytes. How many gigabytes? And then there was a number equation. And because there were 3 variables, one more equation was needed. So that's that one. Let me try one more in this video, and then I'll start a new video for the next question. Let me get rid of that and look for this one. Yeah, let me do this one, and I think the other one is going to take a little more time because of the numbers. Let me paste it here. Now we get Mr. Nick. Maybe it's Old Saint Nick. Maybe this is about Santa Claus going to the amusement park. I will crop that, and I will give some more room like that. This says Nick goes to an amusement park to ride roller coasters, bumper cars, and water slides. I'll call them R for roller coaster, B for bumper cars, W for water slides. The wait for roller coasters is 1 hour. Okay, so the time is going to be the value equation. And let's see, 20 minutes. I don't want to use fractions, so I am going to do everything in terms of minutes. 1 hour roller coaster is 60 minutes, so I'll put 60R. This is the time equation. 60 minutes times the number of times he went on the roller coaster, plus 20-minute wait for bumper cars, plus 15-minute wait for water slides, equals a total of 6 hours and 20 minutes. Well, each hour is 60 minutes. 6 times 60 is 360 minutes plus 20. So there's a total of 380 minutes. So there's my value equation, 380 minutes. Now number equation, it says, Nick wait in line. I'm trying to find where it says the total number of rides. 10 total rides, it says. So roller coaster plus bumper car plus water slide equals 10. And then one more is given. It says he enjoys the roller coaster the most. The number of times he rode the roller coaster was the sum of times he rode the other two. So roller coaster equals the number of times on the, what's B, bumper cars, plus the number of times on water slides. Okay, well, already I see an easy substitution. I can put in R for B plus W, and then I can solve that for R. That's going to be nice. So let me get some more room here. Wait a minute. I need more room. Okay. I'm just putting right here, I'm going to put R, and I just zoomed in instead of wrote. So right here, I'm going to put R for that B plus W. R plus R equals 10. 2R equals 10. R equals 5. Solving for R. So now I know 5 times on the roller coaster, still don't know bumper cars, still don't know water slide. So let me take that now, R is 5, and put it into this equation and either one of these equations. I guess it doesn't matter which one I put it into. I'll just do those two. So I'm going to do 60, and I'm putting in 5 for R, times 5, plus 20, B, plus 15, W equals, and how many minutes? 380. So I'm getting rid of R by plugging in what it equals. And then I'll put it into the second equation. 5, R is 5, plus, I'm putting it into this equation, plus V plus W equals 10. Okay, let me make numbers and get variables on one side. 60 times 5 is 300. 380 minus 300 is 80. So 20b plus 15w equals 80. Got it? And then this one, I have b plus w is 10 minus 5. b plus w equals 10 minus 5 is 5. Okay. Now, why didn't I use these two equations instead of using these two? Well, because these two would have come out everything equal the same, and I would have just been, not those two, these two rather. These two would have had everything the same, and I'd just come out with 0 equals 0. So that wouldn't have helped. But if you did it, and you came out with 0 equals 0, well, then use a different equation. So now I've got to do something to get rid of one of these variables. I'll multiply this by negative 20. Negative 20 times b is negative 20b. I did that because I saw I wanted it to cancel with that b, so I'd get rid of the b's. Negative 20 times w is negative 20w. Negative 20 times 5 is negative 100. And now I'm adding these two equations. 20b minus 20b, 0. 15w minus 20w minus 5w. 80 minus 100 minus 20. Solve for w. Minus 20 divided by minus 5 is 4. W equals 4. Where did I put my values? W equals 4. Now, you can plug these into these other equations, but you know that the number of roller coasters equals bumper cars plus W. Well, okay, I'll do the equation. 5 equals B plus 4. I'll subtract 4 from both sides. B equals 1. By that time, you might, when it's simple like this, you might be able to figure it out. So there it is. Again, value equation, the minutes, number equation. How many total rides were there? And then one other equation was given that allowed a substitution so I could get rid of one variable.